The demand for labor is determined by the marginal product of labor. And in order to increase the demand for labor, you must increase the productivity of workers, which you can do through training and education, or creating better tools for people to use. Now let's take a look at how the supply of labor impacts wages. Here's a mystery of the labor market. The average wage for cashiers in the United States is around $14 per hour. The average wage for cashiers in India is around $1.60 per hour. Why? Being a cashier in India doesn't take less skill than being a cashier in the United States. The productivity of cashiers is pretty much the same in both places. So why the wage difference? The answer has to do with the supply of labor. There are more high-paying job opportunities in the US, which raise US workers' reservation wage compared to India, and also mean that the number of people seeking to be a cashier is proportionally smaller in the US compared to India. To be clear, it isn't a problem that India has a much larger population than the US. That isn't what pushes Indian wages down. It's the lack of other job opportunities that does it. People often wonder why some jobs don't pay as much as others. For example, having been both an economics teacher and a cashier, I can confirm that teaching college level economics pays more than working as a cashier. But why? Of course, some of these differences could be due to productivity. As a teacher, I'm probably more productive in terms of revenue generated from my labor than I was as a cashier. But let's assume for the sake of argument that the jobs are equally productive. Or said another way, both jobs are equally beneficial to the economy overall. There could be a difference in wages if there's a difference in the supply of labor. Far fewer people are capable and qualified to teach economics compared to those who are capable and qualified to be a cashier. And those with a PhD in economics have other lucrative job opportunities that keep the supply of economics teachers pretty low compared to the supply of cashiers. This gives some insight into a common frustration people have with the economy. Markets set prices at the marginal value of the resources used, not the average value. And so people in jobs which provide enormous value to society often won't be paid much if that job is something lots of people can do. Here's another related mystery. Teaching college level economics pays about the same as being an accountant. That's true even though there are around 100 times more accountants than there are economists. And the productivity and skill set of the two professions is not so different. So why, if the labor supply of accountants is so high, do these jobs pay the same? Let's consider the case where they aren't the same. If the supply of accountants is high and the wages for accountants is lower than the wages for economists, then many accountants now have a big incentive to switch. If the skill sets and other qualities of the jobs are largely the same, then you might as well go for the job that pays more. And so the supply of accountants will decrease while the supply of economists increases until the wage gap shrinks. When we talked about the price system, we talked about how prices help organize the economy and direct resources to the uses which are most valuable. That happens in labor markets as well. Wages will be set in a way that helps direct the resource of labor to its most valued applications. And just as the markets help minimize the opportunity costs of the resources used, labor markets encourage those with the lowest opportunity costs to head towards that job. We can see that in this mystery. Teaching college level economics pays, frankly, a lot less than being a credit analyst, a job many people with PhDs in economics end up at. But that gap is persistent. Certainly, the high wage attracts some teachers to go become credit analysts, but not enough to close the wage gap between the two. The answer here is that being a credit analyst is a lot less fun than being an economics teacher. It's a different kind of job, which is more isolated, has a different work-life balance, and has a more monotonous day-to-day experience. And so the higher wages simply aren't enough to compensate for the difference in fun for many people. If two jobs require the same basic skills and education, but one job is simply more fun than the other, then the job which is less fun will pay more because the supply of labor to that job will be lower. This is where our opportunity cost comes in. For me, being a credit analyst comes with a high psychological opportunity cost, but being a teacher barely feels like work to me. That's why being a teacher feels like such a good deal to me. My opportunity costs are low. But there's almost certainly a bunch of credit analysts out there who don't enjoy teaching and don't mind the work they do as credit analysts. Because their opportunity is low for that job feels like a great deal to them. This is the economics behind finding your passion. But I think it offers a more realistic vision of your possibilities. There are lots of passions out there which pay a pittance because everyone is passionate about it. It's too fun, and so it pays poorly. When it comes to your career, you want to search for the thing where you weirdly enjoy something others don't really like. That is the passion you're looking for. One last mystery worth exploring here has to do with risk. Ice road truckers, or truckers who deliver supplies to remote regions in Canada and Alaska, earn higher wages than regular truckers who travel along the better maintained interstate highways. Why? It's the same reason they tried to make a reality show about the ice road truckers, and not regular truckers. It's a much riskier job and has a much higher chance of causing death on the job. Some jobs are more dangerous than others, and that's going to deter people from working those jobs. A lower supply will mean higher wages. What's interesting about this is that the market is essentially setting a price on people's lives. If these two jobs are otherwise similar in skills, education, and other conditions, but only differ in the risk posed to a person's life, then the difference in wages reflects the price people are charging in order to be willing to take that risk. We call this difference a compensating differential, which is a difference in wages that offsets differences in working conditions. Suppose we have two jobs which are equivalent in every way except that one has a high risk of death on the job and the other has a low risk. The high-risk job has a death rate of about 20 in 100,000 people each year, while the low-risk job has about a 3 in 100,000 chance of death on the job each year. Let's say the high-risk job pays $52,500 per year, while the low-risk job pays $50,800 per year. Does that seem like enough of a difference to get you to be willing to take the riskier job? To get a sense of this compensating differential, we can compute the value of a statistical life. In order to calculate the value of a statistical life, we need to take the difference in the salary and divide it by the difference in the risk of death. We can see that the difference in salary is $1,700. A 20 in 100,000 chance of death works out to a probability of 0.0002. which you get by just dividing 20 by 100,000. A 3 in 100,000 chance of death works out to a probability of 0.00003. So the difference between them is 0.00017. Workers in these markets are willing to accept a 0.00017 increase chance of death, or a 0.017 percentage point increase in their chance of death in exchange for $1,700. So what would it take to get them to accept a 100% chance of death? If you divide 1700 by 0.00017, you get the answer, which is $10 million. This calculation offers a hypothetical answer to what the value of a person's life is. Obviously, that's something we cannot truly measure in dollars. However, there are many instances, such as lawsuits for wrongful deaths, where that question has to be answered. Using compensating differentials in this way is common practice for those instances because they are a rare instance in which there is a direct translation between money and the risk of death. Our estimate here is maybe a bit higher than the numbers we see in the real world. In 2020, FEMA, using compensating differentials, calculated the value of a statistical life to be around $7.5 million. Is that what your life is worth?